In this video, we will be discussing lists in R. The contents of this notebook and video are very similar to the notebook on vectors, since these two data structures have very similar interface and functionality. I will assume that you are either already familiar with R vectors or have gone through the vectors notebook. And so I'm going to shorten the description of the overlapping areas between these two data structures, giving only a few examples, and then at the end, I will spend more time on some of the differences. Now, as I said, lists are similar to vectors in R, except that a single list may contain multiple types of R objects, whereas an R vector is constrained to contain only a single type. That means that a list could contain, say, a number, a Boolean, and a string, all within the same list object. Lists can even contain other lists. Notice in the output here that the sublist containing 4, 5, and 6 remains a sublist. If we were to do something similar using the C function in place of both list functions, then all the integers would have been combined into a single list. However, if we did want to concatenate these lists, we could still do this with the C function, but we would need to pass all the lists to be concatenated to the C function rather than as arguments to the list function, as was the case in the previous example. We see that in this example, however, we get a single list in the output containing all the elements from both input lists. Also, similar to vectors, some or all the elements in a list may be named. So if I have this car list here, I can actually add some context to this list by adding labels. Say for the make, the model, the year, and so on. And notice that the output here is different from what we saw with named vectors. The list output prepends $signs to each of the names and uses square brackets with indices for the unnamed elements. And we're actually going to be using this notation in a moment to index these values. Indexing of lists is again similar to vectors in that it allows us to access the individual elements of a list. We may use either the single or double square bracket notation to index the list, and numeric indices, just as before, will run 1 through the length of the list inclusive. So if I'm interested in the first element of, say, the car list, then I would just write car square bracket 1. And this will output both the value of the element at index 1 along with its name if it has one. If we use the double square bracket notation, then we get the unnamed value. And just as before, negative indices omit the element associated with the past index. So typing car -1 here returns all the elements in the list except the first element, which was the make of the vehicle in this example. Using negative indices with double brackets, however, does cause R to throw an error. So definitely make a point to avoid doing that in your code. Also, indices out of bounds will return NA. However, doing so with double brackets will also result in an error. We can index using the names of the elements, just as we did with vectors. And I still need to pass the name as a string, meaning that it needs to appear within quotes. And using the single bracket notation, we'll return the named value, while using the double bracket notation, we'll return the value only. Now recall that when we output the list with named values, they all had $signs prepended to them. This notation is actually a difference between lists and vectors because we can use those modified names with the $signs to index the list without using square brackets. We do this by typing the list variable name, so car, followed by the $sign, and then followed by the element name, so AWD in this example. And the element name here can actually be given with or without quotes, and both will work equivalently. Now, I did not touch on this with vectors, but what happens if we were to duplicate a name within a list or a vector? Now, preferably, we shouldn't do this, but nothing actually stops this from occurring. In fact, we can manually create lists with duplicate names, or maybe accidentally we do this via concatenation. So let's actually do this and create a pair of lists that both contain elements with the name name. Now both list A and B have their first element, creatively named name, with different values. Now let's just concatenate these lists into a single list. So I'll create a variable AB and use the C function to concatenate our A list and B list, and then we'll just output AB. And now we see that the same element name appears in index 1 and index 3. So how do we access, say, the second instance of name? Of course, we can always use the numeric indices 1 and 3 and get the values that we want, but if we try to index on the name, we'll always get back to the first instance of that name. And this is even true if we tried to pass a list containing the duplicated name for each element in the list. So you see in this example here, we get the first instance of name returned for every instance of name in the list indexing AB. Now, there is a function that will return the names of all the elements in the list or vector, and that's the names function. And we can actually use this to create a mask, a Boolean or logical index as follows. Notice that this mask contains true everywhere the name of an element matched our string name in our Boolean expression, and false everywhere else. So if we use this vector to index AB, we'll actually get back each of the elements whose name matched the string name. There are other ways to access duplicate names, but it's likely a better solution to detect this in advance and to handle this before it becomes a problem like this.